So one thing to be aware of, talking about setting these motor speeds, you will rarely use the set method. And the reason for that is set is based on a concept called the duty cycle. And basically what it's saying is, I'm going to use this to set the motor to a fraction of its maximum output. Here's a problem with that. When you're driving your robot, you've got a battery. And when you start the match, that battery's at 12 volts. Over the course of the match, you're going to be driving your robot and doing stuff with your robot. So what's going to happen to that battery? It's going to drain. So maybe by the end of the match, your battery has gone from 12 volts. Maybe it's down to 10 volts now. Well, that voltage is what's supplying energy to your battery, right? Or to your motor controller and to your motor. So if you say, hey, drive at 50% speed at 12 volts, or drive 50% speed at 10 volts, those are two different speeds. And so what can happen is if you're using set like that, you can see a motor become less and less effective over the lifetime of the robot in the match. And so instead what we do sometimes is instead of set, we use a method called set voltage. Yep.
Is that why all this like little RC helicopter is? Because when the battery dies, the motor just slowly gets slower and slower.
It's eventually, yeah, because eventually, even if they're doing it like through a set voltage kind of way, you can drain out like that. So anytime your battery drains, eventually you're going to see the motor try to do what it can, but eventually it's just going to have to give up. Because there is some lower limit on what it's capable of. So with set voltage, it's really nice because all you need to know is the maximum voltage, and then you can multiply your number by that. So, if we were going at 0.25 with the set, it would be 0.25 times, 12 or 13. Don't want to do that. So we'll say 12. So that's the only difference. You just got to multiply it by 12 because that's your maximum battery voltage. And so what that means is now the motor is going to pull more from the battery so that it can accomplish what you're doing. Now, if you're throwing a lot of motors at once, you're going to see your battery voltage drop even faster. You're going to get brownouts. Things could happen, but this is a way to get more consistent behavior. So if you're controlling a motor in very specific ways, you would prefer set voltage over set. But there are still even other ways to control a motor beyond this that you would do more often anyway. But those are probably the two common ways you see, at least with early stuff, is dot set when you're really getting going, and then set voltage when you're like, I know that the duty cycle is going to cause me problems. I'm going to get the voltage specifically.
One thing, you said you had a drift. You can actually put in a deadband. There's a MAF util applied deadband where you can say, okay, it'll zero out anything that's less than a small value. So there's some tricks like that you can use to get around the offset.
Yeah, WPI has a lot of really nice utility functions in it. They're like filtering and supplying. There's a lot we are just barely scratching the surface here. Okay, any questions on those?